Hello, I'm Omar Ford, Editor-in-Chief at MDDI, and welcome to this MDDI Fast Chat. Today, we are talking with Brent Hahn, Senior Vice President at Isometric Micromolding, a niche medical technologies company. Brent is also a 26-year veteran of the plastics industry. Brent, thank you for joining us today.
Thank you, Omar.
Well, let's jump right into what we're here to discuss, and that's challenges in precision molding and miniaturization. I'd like to start by clarifying, what does micromolding mean?
Yeah, I think that's an excellent question because there's truly not one definition. But first, I think we should talk about scale. And to put it into terms I think everybody can understand, a human hair is approximately 100 microns in diameter. 1 micron is 1/100th the thickness of a human hair. And so, I think it's really important to understand that that is how we evaluate our tooling and molding our components and the full assembly. Everyone in our entire company speaks in microns, and I think that culture is very powerful in creating these next generation devices. When you think about micromolding, of course, it's easy to think about parts that fit on the tip of your finger. To me, that makes the most sense. We have an article written about us, and we mold the smallest parts in the world. We have one part that is 0.00004 grams.
Wow.
A green pea is basically the size of a pellet of resin. We can get 1,000 parts from one pellet of resin. So as you can imagine, that truly is micro. But 75% of everything that we mold is larger than a U.S. quarter. And we mold parts up to 7 inches in size. Then they can have a combination of one or many micro features, thin walls, complex geometry, tight tolerances, micro holes. One of the parts we mold is a 96 weld plate, and each one of those welds has a thin wall and an optical surface, 3 thin walls and 3 optical surfaces. So nearly 300 thin walls and nearly 300 optical surfaces, and we're holding a human hair, 4,000 or 100 microns flatness call out from corner to corner. So that's why they turn to us, because again, a nearly 7-inch weld plate is not going to fit on the tip of your finger, but that is still micromolding. And I think that's one of the things that is important for everybody to understand.
So what differentiates micromolding from traditional molding?
Most people are going to say they can do micromolding, but there really is an entire culture around creating this solution. And when you come with these, as I mentioned, all those complex features and tight tolerances and scale or size of the part, let alone getting to volume, it's about being able to overcome hurdles very quickly. We've been doing this a long time. We've built over 7,000 molds and over 1,000 molding projects. And so that history, that experience truly enables us to move forward. But it starts with our expert miniaturization DFM, designed for manufacturability, and DFA, designed for automation. And it starts there, and we look at it with the end in mind of where you want to get to with scale and volume and cavitation of how we're helping you solve your problems. And the enabling factor truly is tooling. Our tooling is sub 1 micron accurate tooling. Now, someone could say, I don't need that. Well, it's so beneficial because it reduces variables. So again, as you think about the end in mind and scalability, if you start with a 1 cavity, then going to an 8 cavity, you still want to be able to validate those parts and be at a high CPK level. And by having that tooling so accurate, you can control your dimensions on the part much easier. So truly, the tooling is enabling us to do this. Then, of course, you combine that with understanding resins. The world uses an 8-inch dog bone to understand resins. That doesn't work in our world. So we created our own dog bone that's smaller than the gate being used for that tensile bar. And we understand now flow, how far the material can flow at various thicknesses. We start at 1,000th or 25 microns thick, one core thickness of human hair. And we have a tab gate and a pen gate, and we use that to understand true shrink, how far the material will flow, as well as gate vestige, for areas. So it allows us to, before we even cut steel, understand your project, your geometry, with your wall thickness and that material combination to create an understanding, a scientific approach, if you will, before we even go forward, so that we can go to the finish line faster than basically anyone else. And then when you think about it, pulling it all together, we have a part that the entire substrate is 5 thousandths thick. So just over the thickness of a human hair. And they wanted to have 3 micron sharp barbs. Okay. And they wanted them to be curved to create a trap steel condition. So when you think about all this together, it comes into creating a solution. So we were able to mold a substrate that's basically the thickness of flash, mold 3 micron barbs, and overcome trap steel in the mold to create a solution for our customer.
Interesting, interesting. How does isometric handle parts with these fine features and at this scale?
Very carefully. Um, we've been doing this for 34 years, and I think that experience truly helps us understand what we're doing. But when you pick that part out of the mold, there's a three-dimensional understanding of where it's at, and we can control that within 1 micron. That way, when we pull it out, of course, one, it's allowing to make sure that the next cycle isn't damaging the mold by a trapped part, but then we incorporate inline automation, and we take that, we put it right into, and we can do truly unlimited amounts of automation. But we have one project where we have an 8 station project, and we're at the end of all 8 processes, we're holding plus or minus 1.5 micron positional accuracy of the entire assembly. And that entire assembly is 1 French in size. So, having that world-class automation paired with submicron tooling and amazing part processing truly enables us to provide a holistic approach to solving our medical device and drug delivery customers' problem.
Brent, what are some of the common misconceptions about micromolding?
Well, I think most importantly probably would be price and speed. Again, since this is all that we do, it's not abnormal for us. This is standard. It is what we do every day. Every employee of our company does this every day. So it's not more expensive. It's not slower because all our equipment, our processes are designed around this. But it's also about understanding, chasing those microns, understanding the variables and how that moves forward throughout the organization. So from the initial tool design, the DFM and DFA, the tool construction, the molding, the packaging, the assembly, if there is, tying that all together. We mold an endoscope tip where it came from a macro molder, and they were able to flow the plastic around these pins to a 2,000th wall thickness, but it didn't knit. So as soon as it was under any stress, they broke. So as we concentrate on thin walls, we flew it around and were able to knit the plastic around so it functioned and was strong as intended. Even halfway down where we're insert molding over a metal insert, it turns gray because it's so thin the colorant can't even follow the resin into that wall thickness, which is, again, half the thickness of a human hair. So you tie it all together, and then we also have sharps. We're molding 3 micron sharps. So that was, I talked about a barb earlier. This is actually a needle with a through hole that's half the thickness of human hair. So a core pin that's withstanding the molding pressures in high volume, half the thickness of human hair. We're getting 3 micron sharps, and we're doing it in very difficult materials like PEEK, bioresorbables, and then also cannulas. And I think this technology is truly amazing. The world currently uses a extruded tube and then manually changing the tip of it to get to that's going to enter the body or stay in the body from up to 9 steps. And it has labor. And whenever you have labor, you're introducing inconsistency. We're molding this right now, 3 inches long, 4 thousandths thick. So thickness of a human hair with a tip that goes down to 25 microns or a 1,000ths thick. So 1/4 thickness of a human hair. With that core pin staying perfectly straight, no flash, no short shot, no human labor, no secondary ops, right out of the press. And this is what's differentiating, this world of micro molding, but true miniaturization, and taking things that are holistically, old school, if you will, to now right out of the press, so much more cost effective, so much faster, and solving the problems of lowering, costs, in the whole medical system by being able to do this right now in the press today. And so again, I think these technologies and these new capabilities are going to continue to push what's out there, and we're excited to be on the forefront of that.
Amazing, amazing. Well, that's all the time we have for today. Thank you for joining us, Brent, for this MDDI Fast Chat.
Thank you.